Beep, bop, bop, boop. Beep, bop, boop. All right, ratio test on number 28 here. Oh, that's not 11.10, it's 11.8. Number 28. Anyways, ratio test to find the radius of convergence. So what do I get on top? I get n plus 1 factorial instead of n factorial, and I get x to the n plus 1 divided by 1.3.5. And I go a little bit further than 2n minus 1. And on the bottom, you have exactly the an, just copying it from above. 1.3.5, 2n minus 1. Okay, so how do I know that's a 2n plus 1 there? Well, you got the 1 times 3 times 5 times 7, blah, 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 up to 2n minus 1. So as you go here, you're adding 2 every time, right? So the next one would be 2n plus 2. 2n plus 1, rather, sorry. Okay, moving on. So what cancels here? Well, 1, 3, 5, all this cancels with all of this. This and what happens? This x to the n cancels with, kills that n there. And then you have n plus 1 factorial over n factorial, which is just n plus 1. So what do you get? You get n plus 1 surviving from here. And on the bottom, you have 2n plus 1. And then you still have x to the power of 1, but that's going to go in the absolute value. Okay, the limit here is 1/2 times absolute value of x. And we want that to be less than 1 for convergence. So absolute value of x is less than 2. So the radius is 2. And here's my, this is not my interval of convergence yet. I want to check the endpoints, right? Okay, so ratio test can only take us this far. Now we have to plug in the 2 endpoints into our original series and see what happens. So say that down here, check endpoints. X is equal to, say, let's do minus 2 first. So what do you get? You get summation n factorial minus 2 to the n all over this odd. It looks like a factorial on the bottom, but it is not. So you're skipping even numbers. Okay, so what do we get here? Simplifying. -1 to the n. N factorial 2 to the n over 1 times 3 times 5, 2n minus 1. Okay, what is n factorial times 2 to the n? I should think about that. I should think about that. That is 1 times 2 times 3, times n minus 1 times n, that's the factorial, and then times 2 to the n still. Okie dokie. Now here we have n factors. What I'm going to do is take these 2's here and put them, I'm going to put one of them with each of those n factors there. Oops. Oh, yeah. Okay. So I take this one times 2 and I get 2. And I take this one times 2, I get 4. And I get times 6 times 2 n minus 2 and then 2n. Okay, coming back over here. Coming back over to this guy, I look at my non-alternating factor, and it is 2 times 4 times 6 all the way up to 2n minus 2, 2n. 1 times 3 times 5, and then it's the last one's going to be n is equal to 1, 2, 3, 4, 5. Yeah, there's n. There are n. Just want to make sure. I was just pausing there because I want to make sure there were n factors in the denominator here, but there are. Yes. So the last one's 2n minus 1, and before that we have 2n minus 3. Okay, now that I'm thinking about it this way, I'm going to look at this and say to myself, oh, that's bigger than 1. Because this is bigger than 1, and this is bigger than 1, and this is bigger than 1. Okay, they're all bigger than 1, right? So Bn is bigger than 1. So I say, so what does that say to me? It says I should use test for divergence. So therefore, limit Bn is not 0. Therefore, limit of An is not 0. I don't know what it is. It may not even exist, but the point is that it's not 0. Therefore, summation An is divergent by test for divergence. And if I do x is equal to 2, that's going to be a similar argument. Okay, therefore, my interval of convergence is, I exclude the endpoints. I can also write this as or -2, excluding the endpoints.